Welcome to the second video in the 802.11 commentary series. In this video, we're going to talk about standard front matter. My name is Tom Carpenter, and I'm the CTO with CWNP, the creator of the CWNA, CWSP, and other wireless certifications for the IT industry. Now, in this video, we're going to be focusing specifically on the beginning pages of a standard from the IEEE. So we'll get an understanding for what these different sections mean and why they're important to us. Before we get into the specifics of this video, let me remind you that the CWNP certification track can take you from a beginning wireless newbie all the way through to a wireless expert. We start out with the CWTS certification, which is for those that are new to the industry, non-techies, project managers, technical sales professionals, those who are just starting out in their wireless career. Then we move on to the CWNA for network engineers and administrators, where we cover everything from wireless network functionality to wireless network planning, implementation, and security. And then we go into the depth. We have the CWDP, CWSP, and CWAP, design, security, and troubleshooting or analysis. So these three take you into the depths of 802.11 and wireless local area networks so that you can design them for large-scale implementations and small implementations, so that you can secure them according to requirements based on government implementations or according to best practices for any organization, and so that you can troubleshoot or analyze these networks when they're not working as expected. And when you've proven your knowledge base and you're ready to become a CWNE, an expert in the industry, then you can move on to that certification, which proves that you've all the knowledge that is required in order to implement and secure and analyze and troubleshoot a wireless network, and you have the experience working in the industry. For more information about these certifications and CWNP in general, you can visit our website at cwnp.com, where you'll find blogs, forums, and helpful information on your journey to becoming a wireless expert. Now let's talk about the front matter in the 802.11 standard, or general IEEE standards for that matter. The first thing you'll generally see is a list of participants after you get past the title page. These are the people that are actually involved in the creation of and approval of the IEEE standard in question. Then we have an introduction section. In the introduction section, you're going to find the basics of why the standard was created in the first place. Then you're going to have contents, tables, and figures. Now this is actually very important. It's in the front of every book, right? And it's here in the standard as well. The contents help you locate those specific things you may be looking for. The tables help you find that nice nutshelled information base for any topic that might be stored in such a tabular format within the standard. And then the figures, these are your diagrams in most cases of how things actually function, such as the architecture of an 802.11 wireless LAN. The fourth thing that we'll look at today is the overview section. In the overview section, we're going to get a scope and purpose statement of the actual standard itself. What is the scope of the standard and why was it created? And then we have the normative references. This is a very important section because it tells you what other documents contain information you'll need to know in order to really master this standard that you're looking at, in this case, 802.11. And finally, we have our definitions, which includes definitions and acronyms. This section is wildly important because as you read through the standard, or if you're just reading a section of the standard and not reading through it, you will encounter terms, and you'll need to make sure you understand the meaning of those terms within the actual standard. Okay, I've told you what the parts are in the front matter. Now let's take a look at it and explore these first 6 sections of an IEEE standard. Here we're looking at the 802.11-2012 standard. We do start with the cover and then the title page, of course, and the notice to users, but we really begin our journey through the front matter with participants. And this is where it lists all of the people that were involved in the development of this particular standard and the approval of the standard. It includes all kinds of important positions that are involved in the development of the standard, and you will notice that it has names you may be familiar with if you've been around the wireless industry for very long at all. For example, you'll see that Matthew Gast, our friend at Aerohive, is actually involved in the standards development process. This is the author of the 802.11 Definitive Guide and the 802.11n book through O'Reilly Press. So some excellent information coming from him, and of course he's involved in standards development as well. When we get to the introduction, we'll see that this has very important information. It tells us why this revision is there. It gives us one document and what the purpose of this revision is from that perspective. But then here is a very important thing. Incorporating published amendments. This lets you know what amendments are rolled into this. So we can see, for example, that 11N, which is well known, very famous, even to those that are not necessarily students of 802.11, because it's on all of the packaging for the devices that you buy today. But it also includes 11K, R, Y, W, P, Z, V, U, and S. These are all rolled into this standard. So as a result of publishing this revision, here's the important statement. All of the previously published amendments and revisions are now retired. In other words, you no longer need to go look at 802.11n to understand the HT physical layer, or the high throughput physical layer. Instead, you come here to 802.11-2012 to understand that physical layer. So we see this. We also see that this revision is going to include technical corrections, clarifications, and enhancements. And then we see a very important thing. Revised clause and annex numbering. There's a simple statement here. It simply says, in IEEE Standard 802.11-2012, the order of clauses and annexes has also been revised. The result of this revised order on the numbering of clauses and annexes is summarized in Figure A. They don't really tell us why, they just tell us they did. And take a look at the changes. So here we see Clause 1 is still 1, Clause 2 is still 2, Clause 3 is still 3, but Clause 4 has actually become Clause 3.3. Now on the left here, we're looking at the 802.11-2007 rollup. On the right, we're looking at the 802.11-2012 rollup. So we see then that clauses start to change. Notice that all of these that are white and not gray are changed, and those that are gray are unchanged. The vast majority have indeed changed. So if you're used to referring to things based on their clause number, it's going to be very important that you review this and take a look at what numbers have changed in relation to clauses in the standard. If you're completely new to studying the 802.11 standard, you don't have to worry about this. Completely ignore this page and just move straight on to the next section of the front matter, the contents. When looking at the contents, it's very important because it helps you locate important things. For example, immediately when we look at the contents, we can see there's an overview, and it tells us the scope and the purpose. We see normative references, definitions, and acronyms. There's a general description here, and a section I really appreciate, how wireless LAN systems are different. This is an important quick section that you should read if you're familiar with wired networking, but not very familiar with wireless networking. For example, we have this great definition of a wireless station. And the reason I point this out is because you'll see this little acronym, STA, all over the place in the wireless industry. It's in white papers, it's in blog posts, it's in training programs, and it's all throughout this standard. So what is a stay or station? Well, in the design of wired LANs, it is implicitly assumed that an address is equivalent to a physical location. In wireless networks, this is not always the case. In IEEE Standard 802.11, the addressable unit is a station, or STA. The term implies no more than the origin and/or destination of a message. Physical and operational characteristics are defined by modifiers that are placed in front of the term station. For example, in the case of location and mobility, the addressable units are fixed station, the portable station, and the mobile station. The station is a message destination, but not in general a fixed location. A station might take on multiple distinct characteristics, each of which shape its function. For example, a single addressable unit might simultaneously be a portable station, a quality of service station or QoS station, a dependent station, and a hidden station. Look at that, a nice, succinct definition of a wireless station. So we now understand every time we see stay or STA that it is referring to a station, and we can then just say station, and that's how I usually read it. If I see that acronym, I just say the word station because it's easier to say than STA. And the station is this logical entity that is able to send or receive messages on the wireless network. So it's very important to utilize the contents in order to find these locations. Then we have tables. Let's say, for example, you're interested in understanding the duration ID field. and how it is encoded as far as the bits go. Well, right here we have table 8.3, duration ID field encoding. We click it and we can see immediately this is a 16-bit field. How do we know that? Because it goes from bit 0 through to bit 15. We see that right here in the column headers. Bit 0 to bit 15 equals 16 total bits. Of course, if we scroll up a bit to the previous page, we can see right here the duration ID field is 16 bits in length. We'll go back down and we can see then the usage of the different bits. What do they mean when they're set to 0, when they're set to 1, when they represent certain numerical values, and so forth. So this table defines that for us, and the tables section is very helpful in locating that information. The figures section helps you find the different diagrams and drawings throughout the standard. For example, you might want to look at the 802.11 architecture. So we can scroll down, figure 411, complete IEEE 802.11 architecture. And when we take a look at this simple diagram, we can see that the 802.11 components from an architectural perspective include basic service sets. We have two of them here, BSS1 and BSS2. An extended service set, which would be these two basic service sets working together. We have the distribution system and the distribution system services. We have the portals that connect to the 802.whatever LAN. It could be 802.3 for Ethernet in most cases. We have the station services. We have the 802.11 MAC and PHY. We have our APs, or access points. All of these things work together to give us our overall 802.11 architecture from a very high-level view. So this is a great figure to know about in the standard. And we have other figures as well. Then there's an important notice, which is right here, and it simply tells you that this standard is not intended to assure safety, security, health, or environmental protection. Implementers of the standard are responsible for determining appropriate safety, security, environmental, and health practices or regulatory requirements. In other words, it is your responsibility to make sure you comply with FCC regulations and do not use output power levels so high in your wireless network that they will steam your vegetables before you're ready to eat them. Now we have the overview section. In the overview section, we get the scope, the purpose, and then supplementary information on purpose. The scope of the standard is to define one MAC and several PHYs, or physical layers, for wireless connectivity for fixed, portable, and moving stations within a local network. This is the scope. The purpose? To provide wireless connectivity for fixed, portable, and moving stations within a local area network. This standard also offers regulatory bodies a means of standardizing access to one or more frequency bands for the purpose of local area communication. But then they go into great detail. The supplementary information on purpose gives you all kinds of detail about exactly what this purpose is. The word usage is important. Notice it says, in this document, the word shall is used to indicate a mandatory requirement. The word should is used to indicate a recommendation. The word may is used to indicate a permissible action. The word can is used for statements of possibility and capability. In other words, if you see a shall statement, that must be implemented in a device in order for that device to be 802.11 standards compliant. If you see a should statement or a may statement, that statement does not have to be implemented as a technology within a device in order for it to be 802.11 compliant. Now, don't confuse that with Wi-Fi certified from the Wi-Fi Alliance. So Wi-Fi certified from the Wi-Fi Alliance must meet their requirements as to what must be certified. But here we're looking at the standard and the word shall. And it's important to know that that is a must within the standard for things to operate appropriately. The reason that's important is if you've got an access point that ignores a shall statement, but a client that is abiding by a shall statement, the two may very well not be able to communicate. So all of these devices or stations, whether it is a client station or an AP station, they must be able to communicate together. So the shall statements have to be there to make that happen. Next, we have our normative references. This is telling you about all of the other documents that are used in order to make this document work. Now, this document is 2,793 pages. It is important for you to understand that in order to make this document actually work, we have thousands of pages of other documents that also come to bear on it. For example, notice right here it says that AES, the Advanced Encryption Standard, is defined in FIPS publication 197-2001. In this standard, it does not define the AES algorithm. It says that AES is used in certain scenarios. Well, we must have something to define the algorithm, and that's what FIPS publication 197-2001 does. Another example is on the next page. Here we see IEEE standard 802.1x 2004. This gives you your port-based authentication used with 802.1x EAP in enterprise deployments. Well, again, we say we're using 802.1x, but in this standard, we don't define all the details of it. In the 802.1x 2004 standard, those details are defined. So it's very important to know that you might need to look at other documents. Some of these other documents may be a little more difficult to get your hands on if you don't have the budget to purchase them, but usually they're explained in detail in books and references that are available to you on the internet. Now, RFCs, on the other hand, are publicly available, so you can look up any of the RFCs by just going to your favorite search engine and doing a search for RFC space RFC number, and then you'll locate that RFC. For example, if I search for RFC 925, I will find multi-land address resolution within Google very quickly, very easily. Then we come to our definitions, acronyms, and abbreviations, the last section we're going to talk about today as part of the front matter. This is where all of the terms are defined specifically as they're intended to be understood within the 802.11 standard. I would encourage you, while for some it might be some dry reading, to actually read through these definitions. Even if you've been studying 802.11 for a while, and now you're going to the standard for the first time. So you've been reading books on it, you've been reading vendor literature, but now you're ready to go to the standard. Read through these definitions because these definitions are based on the standard, whereas definitions you may be familiar with from vendor literature books may not match these definitions exactly. So make sure you read through the definitions and the definitions specific to 802.11. And then, of course, look at your abbreviations and acronyms. So if you jump to a section of the standard and you're looking at a certain clause or subclause, and it all of a sudden uses ACU as an acronym, you can jump up here, find out what is ACU. It's the Admission Control Unit. If you still don't know, you can jump up further to the definitions and read the definition of Admission Control Unit, then go back to your clause or subclause, and it'll make a lot more sense to you. So these are the elements that make up the front matter of the 802.11 standard. In this video commentary, we've looked at the front matter of the 802.11 standard. Thank you for viewing, and watch for the next 802.11 commentary video coming soon.